my goal for today is for you to be able to take an algebraic expression, an equation with x and y, and put it on a graph using the x-intercept and the y-intercept. Now, you're going to be seeing a lot of different forms of equations throughout your time in algebra, but today we're going to focus on standard form. Now, what is standard form? Standard form looks like this. Okay, standard form is a times x, so some number a times x, plus b times y equals c. What the heck does that mean? Well, here's what I really want you to know. And there's a lot there's a lot that you could say here, but here's what I'm going to focus on. X and y are on the, promise that's a note, on the same side of the equation. For standard form, x and y are on the same side of the equation, which is kind of weird. You don't see that a lot, but you see it in standard form. And then the other thing you need to know is that c, you just have a number on the other side of the equation, right? So you have x and y on the same side of the equation, and then you have a number on the other side. There are some things that you'll see when we talk about standard form, like a and b both can't be 0, right? I have to have at least not 0 for one of these, and a, b, and c are never fractions or decimals, right? They're always whole numbers. So it's kind of the gist of it. Now, standard form is not that useful. Don't tell standard form I said that, okay? But it's not that useful, and that's why you don't see it a lot. But the nice thing about standard form is that it's very easy for us to find both the x and the y-intercepts given standard form. So if I have an equation in standard form, I can find both the x and the y-intercept. Okay, so let's try it out. Bet you weren't expecting that, were you? Got one right here ready for you. Graph this function using intercepts. Well, maybe we need a brief refresher on intercepts in general. The x-intercept. Remember the x-intercept? That's the point that's on the x-axis, right? That's the point where the graph crosses the x-axis. Okay? It's also the point where y is equal to 0, right? Because if it's crossing the x-axis, you see this little 0 right here? That's because y is 0 when it's crossing the x-axis. Okay, what about y-intercepts? Well, it's kind of the same but different, right? So we had our x-intercept and our y-intercept. That's the point where the graph crosses the y-axis. It's the point where x equals 0. Okay, it's the point that's along my y-axis. Wherever the graph crosses the y-axis, that's my y-intercept. Okay, so the x-axis is when y is 0. And the y-axis is when x is 0. So let's use this equation. And let's pick a point. We don't know what x is, but where we know that y is 0. So that would look like this. 9x, I don't know x, minus 4 times 0. I'm saying y is 0 equals 36, right? 9x minus 4 times 0, which is y, equals 36. 4 times 0 is 0, and 9x minus 0 is just 9x equal to 36. So if I divide both sides by 9, then I know when y is 0, x is 4. So then on my graph, I can find the point where y is 0, that's along here, oops, and where x is 4. So I have one intercept. That's the x-intercept. Let's find the y-intercept. We're going to do the same thing, except now x is 0. So 9 times 0 minus 4y equals 36. Again, I'm trying to find the point. Maybe I could do that in orange. I'm trying to find the point where I'm trying to figure out what y is when x is 0. So I decided x is 0, and let's figure out what y is. Well, 9 times 0 is 0, so negative 4y equals 36. If I divide both sides by negative 4, y equals 36 divided by 4 is 9, and that 4 is negative, so it's negative 9. So then on this graph, y is negative 9. And now I just need a graph. So in order to graph, let's get my line tool up. All I have to do, and this is my favorite part, all I have to do is connect the dots. I hope you can see that y equals negative, oops. Hope you can see that y equals negative 9 there. Can you see it? Not quite. Right there. Okay. You see that? Yeah. Okay, y equals negative 9. So, okay, let's graph this. And it needs to go connect both of these dots, and you could probably just do that. Right? Just connect the dots. You can extend it if you want. I kind of like extending it, but you don't have to. That's pretty good. So there you go. There's your graph. We just graphed a function using the intercepts. And that's how you use standard form to graph functions, right? We're taking our function. We've got one representation as an equation. We figure out the x and y intercepts, and then we turn that into a graph. I hope that helped you figure out how to graph functions using standard form and getting the x and y intercepts.